Digital System Design Lab, experiment number 2, adder and subtractor. In this video we will be verifying the circuits for half adder, full adder, half subtractor and full subtractor. So before going to this circuit something similar to IO, we'll just once we'll have a look on the truth table and as well as the logic diagram. Now first we'll be verifying the output of half adder. So this circuit has two inputs and two outputs. The first output is sum and the added sum, and the second output is carry if any present. The first we'll consider this input, this pair of input, that is 0 0, and when you add 0 and 0, the sum would be 0 and will not be having any carry, right? So carry also 0. Now we'll consider this case 1 and 1. When you add 1 and 1, the sum would be 0 in binary, and the carry would be we will be getting carry as 1. Now in this case the sum would be high only if any one of the inputs is high. If only if any one of the inputs is high, only then the sum would be high. So once we'll cross check the outputs of this half adder circuit. Here we can see. Just a minute, let me run this first. Okay. So 1 and 0 would give sum 0, sum 1 and carry 0. 1 and 1 would give sum 0 and carry 1, and 0 and 1 sum would be 1 and carry would be 0. So this is how the half adder circuit is. Now we will come to this half subtractor. Here it is, the half subtractor. We can see the logic diagram here, and coming to the truth table, the same thing like the previous one we have added. Now here we just have to subtract the inputs. 0 minus 0 would be 0 and we will not be having any borrow, and 0 minus 1 would give difference 1, and borrow also will be having a borrow, right? When you subtract 0 minus 1, so that's the case here. And when you subtract 1, I mean the 1 minus 0 and do this subtraction, 1 minus 0 will be having the result difference is 1, and borrow would be nothing, I mean 0. When you subtract 1 from 1, then you would get difference 0 and borrow as 0. So this is the truth table of half subtractor. Now we'll check with the circuit that we have drawn. We'll check this with both zeros. When you have both zeros, the difference would be 0 and borrow would be 0. When you have 1 here as second input, 0 minus 1 would be difference would be 1, and borrow also will be getting 1, right? So that's the case here. Now when you switch the first input, I mean if both the inputs are 1, then 1 minus 1 would be 0, and the borrow also will not be having any borrow. So that's the case with half subtractor. Now we'll come to full adder. So here is our full adder. This is a circuit diagram you can see, and this circuit has 3 inputs. Means we'll be having 9 combinational possible inputs. Now then the output will be 2, sum and carry. You can see here, if similar to the previous one, half adder, we'll just have to add these 3 inputs. 0 plus 0 would be 0, and 0 plus 0 would be 0. So in this case where we didn't get any carry, sum also is 0. Now in this case we'll be getting sum as 1 and carry as 0. So we'll be having carry only if two or more than 2 inputs are high. So that's the case. Here we can see there is a carry 1. Here we can see there are 2 inputs. 2 inputs are high. 1 plus 1 would be 0, and so then sum is 0, and 0 plus 0 also 0. So that is the sum is 0, and we will be having a carry of 1. And same is the case with below inputs as well. Let's verify for this. 1 plus 1 would be 0, and 0 plus 0 would be 0. Sum is 0, and when you add 1 plus 1, we will be getting carry 1. So that is the output here. Now we will cross check these outputs with our circuit. This is the full adder. Now first we will check with all ones. So when you add all the 3 ones, 1 plus 1 would give sum 0 and carry 1, and 0 plus 1 would give sum 1, and initially we had a carry. So that is the output here, sum and carry. We will check for 1 0 1. So 1 plus 0 would be 1, and 1 plus 1 again would be 1. So we'll be having carry as 1. So that is the case with full adder. Now we'll come to full subtractor. So here is a full subtractor. We can see the circuit, and this is the truth table for our full subtractor. Now in this case also we'll be having 3 inputs, and we'll be having 2 outputs, that is difference and borrow. So for 3 inputs like 0 and 0 and 0, the difference would be 0 and borrow would be 0. Coming to the last case, 1 minus 1 would be 0, and 0 minus 1, when you do that operation, you will be having a borrow 1 and difference also 1, right? So that is the case here. We'll check this condition as well. 1 minus 0 would be 1 obviously, and 1 minus this 0 would be 1. So the difference is 1, and we didn't have any borrow. So we'll cross check these outputs with our circuit. 0 0 0 would be no difference and no borrow. Let us have a name here like borrow. Run this, and if all the inputs are 0 0 0, there will be no output. I mean difference and borrow would be low. First let us give 1 here. 1 minus 0 would be 1, and 1 minus 0 would be 1. So the difference is 1. I mean it is high, and borrow we didn't get any borrow. If you have 1 1 and 1, then we can see both the outputs are high, because 1 minus 1 would be 0, 0 minus 1 would be 1 in binary, and the difference, so the difference is 1, and the borrow also we have got as 1. So that is how our second experiment, I mean the adder and subtractor is. And I hope all these outputs are correct, and thanks for watching.